Hello guys, welcome to ACEE1, Fundamentals of Deformable Bodies. For today, we're going to discuss about torsion. So what is torsion? In many engineering applications, members are required to carry torsional loads. Torsional loads, these are twisting loads. No? Yung loads na na-encounter natin before is just push and pull, diba? We have tensile forces that pinupull niya, di ba? Tapos yung paano? Basta you get it na yung tensile force it kinds of elongate your body, tapos yung compressive force it shrinks your material. No, dito naman sa torsion, tinitwist niya yung material mo. Okay, so torsion in our introduction to problems is our introduction to problems in which the stress is not uniform or assumed to be uniform over the cross-section of the member. So, here we have a circular shaft. Okay? So, consider the deformation of a circular shaft that is subjected to a twisting couple or what we call yung torque. No? Yung torque natin is designated as T. So, after loading, line AB deforms into the helix AB prime as the free end of the shaft rotates through the angle theta. So, originally, this is line AB, no? Yung, itong solid line na to. This one. Okay? But then, nag-apply tayo ng twisting couple, yung torque T. So, pag nag-twist ka dyan, this is, yung end A is fixed, yung B is free. So, pag nag-twist ka dyan, syempre, yung point A will remain here, but then point B will now move, no? Kasi nga, nagkaroon ng deformation, nagkaroon ng pag-ikot. Alright? So, because of torque T, nagkaroon ng rotation, no? Na-rotate yung surface na to at an angle na theta. So, this thing here, right? So, now, point B is now here, no? B prime. Okay? So, there. This is your example of how torque deforms your body, no? So, ang assumptions natin, we have three. Number one, circular cross-sections remain plane. They do not warp, no? So, yung deformation lang natin is yung twisting, no? Hindi nagkakaroon ng change in area, cross-sectional area, no? Walang warping na nangyayari. Tapos, perpendicular to the axis of the shaft, no? Ayan. Hindi tumatabi-tabingi, kumbaga. Next, cross-sections do not deform. There is no strain in the plane of the cross-section. So, yun na ngayon, hindi rin siya nag-elongate, hindi siya nag-shrink yung body mo. Talagang umikot lang. And third, the distances between cross-sections do not change. The axial normal strain is 0. So, yun na nga, kasi walang elongation, walang shrinkage. So, yung distance nito remains L. Okay? Hindi palibasa, umikot itong cross-section na to, lumiit na si L. No? Hindi. Or, nag-elongate yung L, no? Okay? So, yun yung mga assumptions natin. Okay? Now, each cross-section rotates as a rigid entity about the axis of the shaft. If you will notice, diba, at point B, ito yung rotation. Somewhere dito sa gitna, mas maliit. No? Yan. So, the torque-twist relationship is this. So, we have this formula to find the deformation, yung twisting, no? Yung angle of twist. So, angle of twist, theta, is equal to TL over JG, wherein T is your torque. Okay. So, theta is expressed in radians. Okay, don't forget. Lagi itong radians. If you want to express it in degrees, then you would have to convert. No? So, yung theta natin is equal to TL. So, T is our torque. It can either be in pounds-inch or Newton-meter. Yung length natin could be in inches or in meters. Okay? What is J? J is the polar moment of inertia of the cross-sectional area expressed in inch raised to 4 or meters raised to 4. And then G is our modulus of rigidity expressed in PSI or in Pascal. Alright? Yan. So, next we have the torsional shear stress. Okay? So, ito naman yung stress due to torsion. No? Torsional shear stress. Torsional shear stress is denoted by tau. Okay? So parang yung shear stress natin last time, di ba? It's tau. So, ngayon, torsion siya, pero tau pa rin yung ating symbol. Alright? So, tau is equal to T rho over J. So, T is the same. Torque, J is the same. Polar moment of inertia. What is rho? Rho is the distance from the center of the shaft. Okay? So, if this is the cross-section of your shaft, here, no, depende kung saan yung kinoconsider mo, yung distance from the center, that's rho. Alright? Okay. So, here are some sign conventions for torque, okay, and angle of twist. We have here, sabi dito, positive T or theta. Guys, are you familiar with the right-hand rule? No? You can go check it out na lang sa YouTube kasi hindi ko ma-demonstrate. But, anyway, I'll try demonstrating it to you. So, using your right hand, no? Consider muna natin to, no? Ito. You see that double-headed arrow? Okay? Yan yung direction ng torque. Okay? If you will put your palm down, no? And then, yung thumb mo, i-point mo pa ganyan, you will notice na kapag kinerve mo yung four fingers mo, di ba? Kapag kinlose mo yung four fingers mo, yung rotation niya is pa ganito, di ba? Tama? Clockwise yung rotation. Nasusundan nyo, guys? So, kung ang sinabing torque is pa ganyan, gamitin mo lang yung right hand rule, you will identify na yung direction ng torque is towards there, no? To the left. What about this one? Let's consider this one. So, ano yan? Kung yung rotation is counterclockwise, that would mean that your palm should be facing pataas, no? That's why pag inikot pag kinlose mo yung yung four fingers mo, 'di ba? Yung thumb mo will be pointing in this direction. Right? So that is the tawag dito, right hand rule. Okay? Ganon din yung ano yung term doon? Ganon din dito. The right hand rule also applies here. Ayan. So, sinasabi lang dyan, it's a positive torque kapag palabas siya, negative torque kapag towards your object. Alright? So, yun lang yan. Both of these use the right hand rule. If you are medyo hindi nyo nasundan yung right hand rule na description ko, you can search for it sa sa internet. Marami naman yun, so that you can better understand what the right hand rule is. Okay? There. Next, let's go here. Dito, meron tayong dalawang shafts. We have a solid shaft and we have a hollow shaft. Dito, given na yung formula para sa polar moments of inertia. Okay, for circular areas. So, given na dyan, okay, so merong formula na ang nakalagay ay radius, meron din naman yung diameter. So, for a solid shaft, this is the formula for J. For a hollow shaft, this is the formula for J. You just take note of these. Alright? Next, we have the maximum shear stresses. Okay? Kanina, di ba, sabi, tau is equal to T rho over J, wherein rho is the distance from the center. So, paano ba natin mamamaximize yung shear stress? Okay? Mamamaximize mo siya kapag idudulo mo yung rho or i-consider mo yung radius mismo ng shaft. Okay? That's why the maximum torsional shear stress is equal to T times radius over J. Alright? Now, we just substituted yung formula for J. Kaya nagkaroon tayo ng formula na to for solid shaft and formula na to for your hollow shaft. Okay? So, you just remember these. Or ito at saka ito, diba? You just substitute. Alright? Next, we have power transmission. So, in many practical applications, shafts are used to transmit power. Okay, hindi lang naman yung torque yung ating concern. Concern natin is yung power. Yan, power. So, power is equal to T times angular speed. Okay, omega. Alright, so P is your power transmitted. It is expressed in watts, wherein 1 watt is equal to 1 Newton meter per second. Or you can also express it in pound-inch per second. Or pwede ring horsepower, wherein 1 horsepower is equal to 550 pound-foot per second. Which is also equal to 396,000 pound-inch per minute. Alright, and T is your torque. Omega is your angular speed. Okay, that is expressed in radians per unit time. Formula natin for omega, for angular speed, is 2 pi f, wherein f is the frequency in revolutions per unit time. No? Yung omega natin, that is, yung angular speed is expressed in hertz. Okay, wherein 1 hertz is equal to 1 rev per second. Alright? Now, substituting this value of omega here in this formula, we have the final formula for power transmission to be P equal to T times 2 pi F. Okay, so madali lang naman siya. Ayan. Next, we have statically indeterminate problems. Okay, ano yung parang, technique, technique guys, yan. Parang siya, process to solve if you are given a statically indeterminate problem. Ano nga yung statically indeterminate? Yun yung mas marami yung unknowns kesa sa equations mo. What I mean is yung, di ba, you have summation of forces along y, summation of forces along x, and summation of moments. You have, let's say, 3 available formulas. But then, the unknowns are, kunwari, 4 or 5, ganon, no? So, kapag yun yung situation, then, that is a statically indeterminate problem. Okay, so, ano yung steps na gagawin natin? Number 1, we are to draw the free body diagram and write the equations of equilibrium. Okay? So, yun. Unang-una yun, guys. That's why I'm asking you to write the given. So, as you write the given, you draw the free body diagram. Okay? Tapos, syempre, sundan mo na ng equations of equilibrium, which are summation of moment, summation of force along y, summation of forces along x. Okay? And then, you are to derive the compatibility equations from the restrictions imposed on the angles of twist. Dun sa given na condition, sa problem, may madederive kang compatibility equation that would add to your existing equations. No? And then, use the torque-twist relationships. Okay. So, yung equations natin dito, ayan. This one, dito, ayan. You can use the torque-twist relationships to express the angle of twist in the compatibility equations in terms of the torques. And then, third is to solve the equations of equilibrium and compatibility of for the torques. No? So, we'll encounter this a bit later. Ayan, may encounter na pala natin siya. Proceed muna ako sa discussion. We'll have the problems later. Okay. Let's have this one. Torsion of thin-walled tubes. Okay, so thin-walled tubes are common in construction where lightweight is of paramount importance, such as in automobiles and airplanes. Okay, so ayun, imaginein mo naman, di ba? Sasakyan mo pero pagkakakapal ng mga bakal-bakal dyan, di ba? So, kailangan lightweight lang kasi hindi ka makakatakbo ng mabilis. Okay. Ayan, so there are certain materials, certain things for specific purposes, right? So dito we have a thin-walled tube in torsion. Okay. Kanina 'di ba, yung shaft natin buong-buo. Meron ding hollow pero makapal pa rin. Dito, thin-walled na siya, manipis. Okay, so in figure A, you have a thin-walled tube in torsion. Okay, so, kung mapapansin nyo, so, okay, so manipis siya. Okay. And then, you have here the thickness of your tube, denoted by T. Tapos, ano tong broken line na to? Ito yung middle surface. Okay? If this is the outer, yung talagang gitna nung tube mo. Okay? So, yun yung middle surface. We need that later. We need that sa pagsusolve. Okay? So, you have also the length of the tube and, of course, yung ating torque. Alright? Okay. And then, sa letter B, pinapakita dyan yung shear stresses in the wall of the tube. And letter C is yung shear flow ng dun sa element na yon. Kasi as you twist, nagkakaroon ng shearing forces dun sa loob, and then nagkakaroon ng flow of that shear forces. Okay? There. Assumptions natin, if the tube is prismatic meaning constant in cross-section, and the thickness of the tube is constant and is small compared to the overall dimensions of the cross-section, the torsional shear stress is almost constant through the wall thickness of the tube and directed tangent to the middle surface. Okay? So, ano ba yung shear flow? Shear flow, ang notation natin for shear flow is Q. Okay? It is defined as the shear force per unit edge length of the middle surface. Okay, that's why yung ating formula for shear flow is equal to tau times T. Okay? Okay, so for the assumptions mentioned above, the shear flow is constant throughout the tube. Okay? Relating shear flow with the applied torque, we have Q equal to torque over twice the area. Okay, A naught. Ano ba yung A naught na yan? Dito ba? Wala pala. A naught, guys, is yung area covered by this middle surface. No? So, kukunin mo yung gitna nung thin-walled tube mo, tapos kung ano yung area enclosed by that perimeter, yun yung A naught. Okay? Yun siya. Okay. And then, the angle of twist is given by theta equal to TLS over 4G A naught squared. Pero guys, meron tong T, no? Yung thickness ng tube, meron yan dapat ditong T. I just forgot. So, there. And then we have the sample problem. Okay. So, that's the end for the lecture on torque, guys. Thank you.